Hello everyone, my name is András and I am going to talk about a method-level dataset on test-to-code traceability. If you want to assure the quality of a software system, then you will probably want to write a lot of tests, because tests are a great way to uncover bugs. Then your code is partitioned into production code, which is the software itself, and test code. If you have a lot of tests, then telling for each of these tests which parts of the code it was originally meant to evaluate can be really hard, but it would be beneficial, for example, if the test fails. This is a valid problem of software engineering, and it is called test-to-code traceability. There are already several methods that try to cope with this, but publicly available evaluation data on these are still very rare and mostly limited to class level. The real benefits would come from method level information. Here we can see an example test case from the JODA-time system. It evaluates the isAfterNow method of the system, which tries to determine if a given date and time is after our current date and time. Since our current date and time changes constantly and we would like a test to perform consistently, the system uses these yellow methods here, set up and tear down, to set the current date and time back to a specific date and time. These we will call helper methods. There is also the test itself, and there is the method under test, which we will call focal method. There can be more than one focal methods for a test, but there are also these blue methods here, which also contribute vitally to the success of a test, but were probably outside of the intentions of the author, since, for example, here, the isAfterNow method, which uses one parameter, is tested by other tests also. So you can see a basic limitation here, because we also try to capture the original intentions of the author, which is really hard and less prominent on class level. So we classified these methods into four categories: test cases, focal methods, test helpers, and contextual methods, which are also called production context, which also contribute vitally but are outside of the real scope of the test. So we present the TestRoutes dataset, which considers 4 open source Java systems and contains data on 220 test cases with 866 methods altogether. On the left side here, you can see a graph from JODA-time. The green nodes represent the test cases, and you can see that there are several interconnections between these nodes. Here you can see data on the systems that we considered. These are medium-sized software systems with thousands of production methods and thousands of tests. We enlisted the help of a graduate student who did the actual manual annotation. The student did not run the code beforehand, but worked in a development environment and studied the structure of the systems before, and was familiar with the goals of each test. We held several review sessions with the student and addressed the cases he felt unsure of, and even exchanged some of the test cases afterwards, which we found highly subjective. Our data contains 2 types of files. The first is the routes file, which contains the classifications. The first identifier is always the test case. The second one is always the method that is classified into focal, contextual, or helper. The data files contain data on these identifiers, the qualified names, and the line informations. So we presented here our data set, which is highly detailed compared to the other publicly available data sets and could provide common ground in the evaluations of test-to-code traceability techniques, both on method level and class level. Thank you for the attention and feel free to check us out on GitHub.